This conference will now be recorded.
Hey, welcome to containersindia.net. My name is Rajshekhar, and today we are going to discuss what is a container. So, if you have a good understanding on operating system, container is nothing but a normal user space process which looks like a virtual machine to the end user. So let me explain you this in detail. So usually we install operating systems on hardware. So the hardware could be a physical hardware or could be a virtual hardware. So when we talk about hardware, we talk about CPU, memory, network, and storage. Means hard disks are centralized storage. So we install operating system on top of this. When we install operating systems install kernel for you. Kernel would be the core component of any operating system which manages CPU, memory, network, and storage. So, and the space between this space we call it as kernel space, and this space we call it as user space. When we when we log into operating systems like Linux, we will be connecting to a process called shell. So we have different types of shells like bash shell, C shell, sh shell, etc. So logging into the operating system in Linux means connecting to a process called shell. So if you look at the first process in Linux, it is the init process, and all of the rest of the processes are forked from the init process, and shell is also one of the processes. So in simple, user space is all comprised of processes, and the first process is the init process, and the init process is forked as multiple processes. And if you look at the grandparent process of the all any of the process is init. So if I want to store a file on hard disk, and if I am a user on that operating system, I can't directly interact with the hardware. Instead, I interact with the shell. Inside the shell, I execute commands. These commands will interact with kernel using library calls. Then kernel interacts with the hardware using functions called system calls. So this is a short description about operating system, and if you know operating system, a container is nothing but a normal user space process which looks like a virtual machine to the end user. For end users, it looks like a virtual machine, but actually, with respect to the host operating system, it is a normal user space process. If you look at the characteristics of a process has usually we identify processes with number, and that number we call it as a PID. And if a process is a server process, usually it listens on some port, some network port at network stack at layer 4 to accept requests. Means it is bound with the network. And usually processors write their logs to files on some mount point. We can see two processors communicating with communicating among themselves using something called IPC, inter-process communication, is a mechanism which lets two processes to communicate with each other. A process would be usually owned by a user and runs under the authority of this user and the groups. If you see, these are few of the properties of a process. And what is a container? Container is nothing but a normal user space process which has a PID with respect to the host operating system and which looks like virtual machine to the end user. So let's see this in detail. I'll show you a demo. So if you observe here, I logged into my host operating system machine as a user called root user. So if I want to run a container, usually I run a container, and if I am using a software called Docker to run containers, I run containers using Docker container run and the image name. For example, Nginx. So if I run like this, the container will run in foreground mode. If I want to run it in a background mode, I have to use an option called -d. So now if you see this, the image is being pulled from image registry, and the default image registry that Docker uses is hub.docker.com, and the image is being pulled from hub.docker.com, and the repository we are using in hub.docker.com is library, and nginx is the image name, and we are using latest tag to download. Now if you see the newer, this states like nginx colon latest image got downloaded. We can check that using docker docker image ls command. So if you see nginx image got downloaded. So if I want to run a container, I run it like this: docker container run nginx colon latest. So actually docker container run -d command runs a container for you. If the image is not present locally, it first downloads the image for you and then runs the container for you. So docker image ls is the command to see whether the image has been downloaded, and yeah, we can see that the image has been downloaded to our host operating system. Now we can see whether the container is running or not using the command called docker container ls. And if you see that command, a container with id this one and based on nginx image and with name dreamy hoover is running. So like I explained you, what is a container? Container looks like a virtual machine to the end user. So let's see how it looks like a virtual machine to the end user. Now if you see, I am into my host operating system, where my host operating system host name is this one, IP-172-31.36, IP-172-31-36-149. So if I go into my container, so the command I have to use to go into my container is docker exec-it, and the container name bin bash. So I am into the container. If you look at the host name of the container, this is the host name of the container. So if you see, the host name of the host operating system and the host name of the container, both are different. So this is one of the informations based on which I told you a container looks like a virtual machine to the end users. Means a container will have its own host name and it may consume its own resources. And if you look inside the container. And if you see the file systems, presently my present working directory is slash, and if you see it has very less subdirectories compared to the host operating system. If you see how many subdirectories it has at slash level, 19 subdirectories. If I go into my host operating system, and there I will, if I execute the same command ls slash wc-l, so 25 subdirectories are there at slash level, but inside my container I have only 19 subdirectories. So a, a container looks like a virtual machine to the end users. But actually, what is this container? If you see the container will have its own operating system, and it will have very minimal operating system binaries. And if you clearly observe, if I want to look at the IP address of this, and if I am using a command called ifconfig, the command would not be present inside this. Means it won't contain all the commands. Usually container contains very minimal commands, which are, and that too the commands in the sense binaries, which are required for an application to run. It won't contain all unnecessary binaries. So if you want to check what are the processes that those are running on this container, which looks like a virtual machine, even the ps command is not there inside this container. So we can install if you want. And I know like this Nginx is based on Ubuntu image. I'll use apt-get command to install this. So to install this, apt-get update, which updates the repositories, apt-get install proc ps install ps, it the above the command which I have executed installs ps command, as well the command that I'm going to execute now, apt get install net-tools, is going to install ifconfig related commands. Now we can see what is the IP address of this container. The IP address of this container is 172.17.0.3, and if you look at the processes running inside the container, ps-ef, and you see the processes running inside the container. The first process with PID1 is nginx colon master process nginx-g daemon of semicolon. This is the master process is the process with PID1, and there is a worker process with PID6, and the parent ID of this worker process is 1, which is a master process. So the container itself looks like a virtual machine to the end user, but actually, like I explained you earlier, this container is a normal user space process on the host operating system. So let me show you how this is a normal user space process. So for that purpose, what I'll do is I'll open another terminal, pwd. I'll paste ssh-i ubuntu at ec2 34 244 199 and 36 dot eu hyphen west hyphen 1 compute amazon aws.com. I'm opening another terminal, and I logged into the same, and if you observe this, and if you look at the parent ID, the PID with the process with PID1 inside the container is Nginx master process. So if you look at the child process, this is a worker process. So let me kill the worker process and see what will become the PID of the worker process. So to do so, the commands are very simple. There is a command called docker top and the container ID or container name. The container name is this one. So it shows the PID maps, like the PID inside the container to the PID of the same process at the host operating system level. What it means is, what the above command is showing is the master process PID at the host operating system level is 23639 and the worker process PID at the host operating system level is 23687. So let me kill the worker process first. Kill -9 23687. So the process got killed, and now if you observe, the child process got spawned and a new child process got spawned, and if you look at the PID of the child process is 375. So the container has here a container called Nginx has two processes. One is a master process, another one is a worker process. Like I told you, though the container looks like a virtual machine to the end user, actually with respect to the host operating system, it is a normal user space process, and we have killed normal use we have killed one of the user space processes which maps to the worker process, and master process has spawned up a new worker process inside the container and it has given a PID 375. But if you look at from the host operating system's perspective, what is the PID of the worker process? It has changed. Earlier, the PID of the worker process is 23687. Now, the PID of the worker process has been changed to 24401. Now, let's kill this process also as well. Kill hyphen 9 24401. Now, let's observe what is happening inside the container. So if you observe, the master process has spawned up a new worker process with PID 377. Means if we are killing the worker process, master process is it's spinning a new process. I mean, a new process is getting spawned up every time. But what if we kill the master process itself? So if we kill the master process itself, there won't be anyone to restart the master process and the container will be killed. So let's kill the master process, kill -9. The PID of the master process is 23639. 23639. Now I have killed the master process. Now if you observe, the container got killed. The container got killed. So now in short, what is a container? Container is nothing but a normal user space process at the host operating system level. So, and if someone is killing a container, no one would be there to restart that container. To restart the container, we may need to use container restart policies, or we have container orchestration tools like Kubernetes, Docker Swarm, etc. So, so if you if you want to learn more on these technologies, container technologies and Kubernetes technologies, please visit us at containersindia.net or call us on our phone number which is available in our site. Thank you for watching this video. Have a great day.